Hi guys, good afternoon. So in the last session, we have seen until the route reflector. Now today, we'll go with the next concept, which is about BGP Confederation. Now, why we were using the route reflector? To reduce the, see here, to get rid of the full mesh adjacencies, we used two methods. One was route reflector, another one is confederation. Okay. So let's go with the confederation. So we'll take an example. We don't have the didn't get access for what? Which module you didn't have the access? Okay, so we'll see at the end of the session whatever. Now see here. So we can say this is another method to reduce the number of full mesh adjacencies or to avoid the full mesh adjacencies, right? Now, in case of confederation, you use the concept of sub-autonomous system. Okay. Here we use the concept of sub-AS or sub-autonomous system. Okay. So the sub-AS, okay, will not be visible to the outside ASNs. Okay, to the outside ASNs, only your main ASN will be visible. Okay, the main ASN will be visible, and the sub AS they will not be visible. Okay, and for this region, for creating the sub AS, we use what? Private ASN range. So sometimes these are also the sub AS. Also known as private ASN. Okay, and the range of private ASNs we have already seen, right? Like here, this is the range. This is the range. Private ASN range. Clear? Now, for confederation, we don't have as we don't have a spatial type of configuration. Just two extra commands are there. That's it. Where one command will define that what is the main ASN number, and the second command will define that what is the sub AS. These are the two commands. So these commands we will configure only in the IBGP routers. Okay. So just note down the comments, then we'll see the practical about it. In case of confederation, we have to use two extra commands on the IBGP routers. Command number one. So first of all, you will go like router BGP ASN. Okay. Then you will go with whatever the neighbor is there, that neighbor you will go with neighbor ID, remote AS, and the ASN. Okay. Then what are the commands? We have to use BGP confederation. One is identifier. So with the identifier, you use the main ASN or the actual ASN. So this ASN will be visible to your outside world, and another one, BGP confederation PM and the sub ASN. These are the two extra commands we have. Clear? Understood? These are the commands. So now let's go to the lab and see. So this is the confederation lab. Okay. So here we will have one eBGP, and these are the iBGP routers. Okay. And here the ASN number is 12. Okay, we are using the ASN number 12, and inside the ASN 12, we are using two ASNs, which is 23 and 45. That means one ASN we divided into sub ASN, right? Okay. So let's wipe out all the nodes and let's start. And then meanwhile, the routers are coming up. So on R1, we have a loopback as well. And then we'll say router BGP 1. So first of all, we'll configure the neighbor. Neighbor ID will be 12.2, because this guy will become the neighbor. What will be the remote AS? So like I said, to the outside world, only your main ASN will be visible. Okay. To the outside world, only your main ASN will be visible. Clear? Okay. So remote AS is 12. This is clear? Okay. Then after that, network 1.1.1.0, and then subnet mask. Okay. And the subnet mask is yes, sorry. I was typing this thing. Okay, not clear. Mask will be, this is done. R1 configuration is done. R2. Z0 by 0 is 12.2. This is okay. Three interfaces we have. Z0 by 1 will be 23.2. Z0 by 2 will be 24.2. Now here it is important. Router BGP. So now you see here, this is ASN 23 and this is ASN 12. Which one you will give? Why? Yes. So here, whatever the configuration will be there, that configuration will be according to sub AS. That configuration here will happen according to sub AS. So what you'll say? Router BGP 23. Okay. Then after, here we have to give the neighbor. Neighbor. Then what is the neighbor ID? Now one neighbor is 23.3. So 192.168.23.3. Remote AS. So what is the remote AS? 23 only. Then another is 24.4. Remote AS will be 45. This is clear. But here now we have to attach the main AS also. So how we will say? We will say BGP Confederation identifier. And what is the main ASN? Main ASN is 12. Okay. And then we will say about peer. BGP Confederation peer, and peer is 45. This is clear. Okay. Then R3 configuration. So I'll just copy this BGP configuration. R3 Z0 by 0 is having the IP address 23.3. Z0 by 1 will have 35.3. Router BGP 23. One neighbor will be 23.2 and another one will be 35.5, right? And this will be in the 23, this will be in the 45, and main ASN is 12 and peer ASN is 45. This is also clear. Okay. Now same configuration for R4 as well. So Z0 by 0 will be 24.4. This will be 45.4. Main ASN is 45, peer is 23. One neighbor will be 24.2, which is in the 23, and another one is 45.5, which is in the 45. This is clear. Okay. Then R5. So let's copy only this much part. Identifier will be your main ASN only. Though multiple lines will have. So Z0 by 0 is 35.5 and this is 45.5. This is 45. Now one is 35.5, which is in the, sorry, 35.3. One neighbor is 35.3 in the 23 and 45.4 in the 45. Main ASN 12, peer ASN 23. This is clear. Okay. Now let's take access of these routers. R1. Okay, in for R1, what is the ASN number? One only, right? Yeah. R2, R3, R4, R5. Now, this is R1. Copy. 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 So we should be able to see the neighborships. So here it is neighbor with 23.3, 24.4, not neighbor with R1. Something is wrong between R1 and R2. R1 interface G0 by 0 is 12.1. Neighbor IP is 12.2. Remote AS 12. That is okay. Okay, this. Okay, neighbor I have not given here. One statement will be there. Neighbor 192, 168, 12.1. Remote AS 1. In this one statement we have to do. On R1 or R2. Remote. Now we should have a neighborship between R1 and R2 also. That is fine. So if I check to show IP BGP, so you can see 1.1 since it is locally originated route. So that's why it is the best route. That is fine. Do show IP BGP. This is also the best route. And next stop is 12.1. And let's check, does R5 have a route or not? Do show IP route. BGP. No routes. Okay. Do show IP route. BGP. R4 also no route. Do show IP route. BGP. R3 also no route. Do show IP route. BGP. We have this route. Okay, this is coming on R2, but it's not going on R3. Do show IP. BGP. So this is there, but it is not selected as a best route. You see, then information is there, but it is not being selected as a best route. Because for a route to be installed in routing table, reachability must be there. And you see what is the next stop here? 12.12.1. So 12.1 it is telling us here. Now 12.1 is who? Let's say how R3 will reach 12.1, right? So for reachability, we can use in the IBGP, we can use, any OSPF, HRP, all these protocols we can use. But other than that also, why the next stop is for everybody, it is coming 12.1. We have to say next stop self. We have to use the next stop self command, right? So what we'll have to do, see here, for these two neighbors and on basically for all the IBGP routers, we have to use next stop self, because although they are in IBGP, the main ASN is same, but the still sub ASN is what? Different. Okay. This thing I'll use here. Same way on R4 we will use for R5, and on R3 also we will use for R5. Okay. So that means whatever the routes they will advertise, 23.2 and 35.5. Hmm? If RP is connected in other IBGP protocol, you use next stop self in the RP. See, next stop self when the route is coming from a different AS. So let's say on R2, if I see, so on R2 for R4, I have to give. Same way on R4, I have to give for R5. Like this, I have to give. Same way on R3, I have to give for R5. Then no need. Then no. But again, to break the split horizon, you will need a full neighborship. Yeah, there you will. Correct. Okay. So now take a look. So here we have 24.2 and 45.5. This is R4. Right. 45. This is R4. So these are the two extra comments we will use. Okay. Now let's check again on go to IP BGP. You see, now this time it is selected as a best route on R4. Best route. See, this is clear. Okay. Now I have the route and I have the best route. If I try to ping from R5 to R1, will I be able to ping? Because if you check in the routing table, do show IP route, BGP, will I be able to ping? Yes or no? If I say do ping 1.1.1.1, I'll not be able to. Hmm? Is it 35.3? I'll not be able to reach. Okay. Why I'm not able to reach? Because in Confederation, you need a loopback interface. If you want to communicate, you need a loopback interface. So right now, when I'm generating the traffic is getting generated from my physical interface. But if I have loopback, let's say interface loopback 1, IP address 5.5.5. Okay, let me try to ping. Let's say 12.1. If I try for 12.1, I don't even have a route. So I'll not be able to reach. Okay. So I'll say interface loopback 1, IP address 5.5.5.5.255.255.255.0 done. Now, if I say do ping 1.1.1.1 source loopback 1. Okay. Am I able to ping? No. Okay. Now, see router BGP 45. Then I'll say 5.5.5.0 mask 255.255.255. Done. Wait for it. So you will have to add a loopback. With the loopback, you'll be able to is that clear? That means when you're generating the traffic from the router. This is clear? Any doubt? Okay. Then next heading, summary in BGP, that is known as BGP aggregation. BGP aggregation. So how do you summarize the routes in BGP? You have a simple command summary address, or sorry, not summary, aggregate address. Okay. So what do you have to do? The BGP aggregation is used to reduce the size of BGP routing. Okay. So to aggregate number of routes into one using BGP, we use the aggregate address command. So what you'll do, you'll say router BGP ASN, then you're going to say aggregate address, then here you'll give the summarized network, and then the summary mask. Okay, but there is a problem with this particular command that along with the summary, it will advertise individual routes also. So this command will advertise summary, but it will also advertise individual routes. To advertise only the summary route, we use the following command. Here at the end, you will add one word, that is summary only. Now it will advertise only the summary. Clear? Clear? Yeah, redistribution and SL. Okay. Now let's go. Don't have for aggregation. Okay. So this side I'll not use this one. This side I'll use 16.0.0/24. Okay. So like all the loopbacks will be dot one. This will be dot one. This will be dot one. Dot one and dot one. So let's go. 12.1. This will be dot two. Then neighbor is ASN number 12, ASN number 12. Networks we will advertise. Done. Then R2 we have only one IP address. Of this neighbor 12.1, all these things are not required. Done. Remote ASN curve. This is also okay. Let's take an access. No. Copy. R2. Copy. So let's wait for it. Neighborship will come up. Neighborship is up. So let's check. Do show IP route BGP. Still nothing. Do show IP BGP. Wait for it. These are all there. These are the best right now. Now we can see the routes are there. Okay. So right now we can see the individual routes are coming. And if I check to IP route BGP, here also we can see. Now I want to advertise summary. So to advertise the summary, the command will be aggregate address. Then what we will have summarize network. So if I will summarize it, it will be into /22. So /22 means 252.0. Correct? Okay. Done. Now let's check here on this side. So we got one /22 here. But along with the /22, we also have what? Individual routes. So I don't want these individual routes. So what I can say? I can say summary only. That should advertise only the summary. Now check. We have only the summary. This thing is clear. Now, Related to this, like in EHRP, we had leak map. Same like that, we have here also such concept. So that is known as BGP, suppress map, and unsuppress map. So note it down. So BGP, suppress map, and unsuppress map. First, we'll talk about suppress map. Okay. So suppress map is used to block specific routes. Okay, you are advertising summary, but other than the summary, you want to block specific routes. It will not advertise a particular route from the summary. Okay, so you can say number one, suppress map, VGP. Suppress map is used to block specific routes. Okay, from summary and advertise other routes along with. Okay, so it's like, let's say earlier when we say summary only, so I was advertising only the summary, but I want that okay, few routes should go and few routes should not go. By default, all routes are going, but if I say summary only the summary is going. Okay, so in that case, to select the route, we will use ACL. Okay, so first thing you will do is create ACL. Access icon list, then you will give the ACL number, anything between 1 to 99. Then you will say permit, and here the network you want to block, right? So then network ID and wildcard mask, or let's say 2. If this way you will understand. Once this is done, now to define the action, we will use route map. Route map, then here you will give the route map name. Then you will say permit and sequence number. After the sequence number, you will say match IP address, and here you will give the ACL number. Once you have given the ACL number, now we will attach this route map with the summary command, aggregate address. Okay. So what you will do, you will say router BGP ASM. Then you will say aggregate address, your summary network, summary mask. Okay. Summary only. Then you will say suppress map. And then your route map. This is the thing you're going to do. Clear? So this is your suppress map. Note it down.
Suppress map is to allow a particular router block.
Block. Suppress to suppress the route, unsuppress to allow the route. Okay. So in the unsuppress, there will be a slight change. Neighbor ID. Okay. And you will say unsuppress map and route map. This is the change. Here we are deciding. Here we are telling what is the action you want to suppress or unsuppress. If it is suppress map, you are allowing it. If it is unsuppressed map, sorry, if it is suppressed map, you're blocking it. If it is unsuppressed map, you're allowing it. Okay. Noted. Let's go to the lab. So right now you can see I'm advertising summary only. Correct. So let's say I want that, okay, this 16.0 and 16.1, or let's say only the route 16.0 should not be advertised. Whatever the number you want, that you can decide. So you will create an access list. Access list 1 permit, let's say 172.16.0.0, 0255. This is one. And another one I want to use in the same access list, 1.0, right? Then I can create route map, name, RMAP, permit, sequence number 10, match access list, sorry, match IP address. ECL number is 1. Then just go to router, BGP 12, and the same aggregate address command we used like earlier. We used aggregate address command. Okay, let it be. Oh, this is R2 actually. Sorry. No route map, RMAP, no access list on R1. Access list 1, permit 172.16.0.0.0.255. Then this is 1.0.255. Okay. Permit 10. Match IP address. The IP address ACL number is 1. About BGP curve. The aggregate address command. And here, after this, I'll use, sorry, suppress map and the name of the route map. Once this is done, let's verify here. Do show IP route BGP. 0 and 1 is not advertised, and 2 and 3 is getting advertised. This is clear. Same way, if you want that, okay, unsuppressed map. So again, ACL and route map configuration is same, right? So instead of this, I'll say, so this one I'll say no. Okay. And let's say I'm advertising summary only. Right now I'm advertising summary only. So I should see only the summary. Where did I say no? Right. I said aggregate address 1600. This is the summary, and I'm advertising summary only. So now I should see only the summary route. Okay. Now, along with the summary, I want that, okay, 1.0 and sorry, 0.0 and 1.0 should be advertised. So instead of suppress map, same ACL, same route map, I will apply in unsuppressed map. So I'll say neighbor ID is 192.168.12.2, unsuppressed map, and route map name is R map. So to this neighbor, also 0.0 and 1.0 should be advertised for it. Yes. So in the unsuppressed map, we allow those specific routes, and in the suppressed map, we block the routes. This is clear. Online people clear?
Yes, sir.
Yes. Suppressed map, like no summary is not working. No summary. Sorry, summary only is not working. Summary only is working. Means it will advertise separate routes also, summary route also. No, if you say summary only, then only summary it will advertise. But there is a right? Where? Suppress. You mean to say suppress map? Yes. Okay, let me do one thing. I removed the unsuppressed map. Now I'm saying only summary only, right? Yes. This is summary only. So now I will have here summary only. So here, right? Only summary is there. Now if I will apply suppress map, so whatever the routes I will block, those routes will be blocked and remaining routes will be advertised. Yes, sir, but when summary is only that we use summary only for that one single to advertise. But here it will advertise summary also and other stuff. Other routes also. Yes. So, but so if you don't want other routes, you don't need to give us unsuppressed map, right? Automatically it will advertise only the summary. It is kind of leak map, you can say. The same kind of leak map configuration. You are advertising summary also, but there are one or two routes that you want to advertise. Without summary only, we can use that. If you say without summary, no, without summary only, you cannot, right? If I don't say like this, and if I try, okay, here also you can use, let's check. Suppress map, R map. Then it will not advertise the summary only, I guess. If you want to bring it is working the same only. No, by default it advertises all the routes. So that is also the same case, right? Summary is still getting advertised. When we use the aggregate address command, see, by default, two conditions are there. That if you do not use the summary only, it will advertise the summary as well as all the routes. So you use suppress map to block a specific route. That is one case. And another case that you want to advertise summary, but along with that, again, you want to, that means condition is the same. And whether or not in this case you use summary only or not, both works the same. Is that clear? By default, all the routes are advertising. Along with summary. So in that case, when you want to only specific route to advertise, deny. In deny, you will use suppress map. So when without using summary only, with summary only, same thing. Okay. Yeah. All right. Then Last topic, BGP attributes. Okay. So according to your CCNP level, we have 4 attributes to discuss. We have weight attribute. We have local preference. We have AS path preference. And we have MEP. These are the 4 attributes. Let me start the lab. So while we will understand the lab. Mhm. Those are like calculations on, like if you check in the, okay, like already the routers are off. Later I'll see. That means these are the ones which are shown when you use the command show IPBGP, which can, these are the ones you can use to manipulate the port. Okay, this is the kind of scenario we have. Here we don't have the IPBGP. Okay, let it be, we'll see. So while these are coming up, so let's talk about the first attribute, which is the weight. If you talk about weight, weight is Cisco proprietary. Okay. And higher weight is pro. Okay. And the weight is ranging between 0 to 65535. Okay. It's between 0 to 65535. And your weight is updated whenever you want to, whenever you are receiving an update. Okay, whenever you are receiving an update about a route, that time, see, weight is local to the router. Weight is local to the router. Okay. So whenever you are receiving a route, that time the weight is going to be considered. Okay. So you can say this is set when receiving update for any route. The default value of weight is 0 for receiving the route. Okay. And the default value weight is 32768 for directly connected, or you can say locally originated routes. This is clear. Your weight is local to the router. That means it will not affect any other ASM or any other router. If you want to manipulate the weight on a router, you will use router BGP ASM. Neighbor ID, weight, and the weight value. This is clear. Okay. R1 loop back is 1.1.1. Z0 by 0 is there, Z0 by 1 is there. So Z0 by 0 is 12.1. This is 14.1. These loop backs are not. Neighbor ID 1 is 12.2. This is localization 1, remote ASN 2, then remote ASN is 4, and this is 14.4. R1 configuration is done. R2, this is, so 1 is 12.1, remote AS1 13.23.3, right? 23.3, remote AS is 3, and this is done. And then we have R3. Okay, 2 interfaces are there, right? Before that, let me just go. So R3 or R2 first, 2 interfaces are there. One is 12.2, another one is 23.2. This is all okay. R3, Z0 by 0 is 23.3. Z0 by 1 will be 30. 4.3, loopback will be interchange. Okay. ASN number 3, and one of the neighbor is 23.2. Another one is the 34.4. This is in the 2, this is in the 4. Okay. And loopback is 3.3.8. This is clear. Then R4, Z0 by 0 is, I guess, 14.4. And this will be 34.4. One more loopback is there. So one is 34.3 in the ASN number 3, 14.1 ASN number 1, 4.4.4, and this will be done. ASN number, sorry, 4, 3, 2, 1. R1, R2, R3, and R. Copy R1, copy R2, copy R3, copy everybody should have at least two neighborships. Okay. R1 has two, R2 has two, R3 also two, and R4 also. Yeah. So let's talk about, let's say R3 is there. If I check do show IP BGP, okay, first let them select the best routes. BGP is TCP based, so comparatively slow. Okay. So let's say R3 is there, right? On R3, if I see if I want to reach, let's say 2.2. If I want to reach 2.2. So what is the path it is preferring? Is it star means valid, greater than means valid and best. So which one is the best route? 23.2. Now I want that, okay, for 2.2 also it should prefer what? 34 dot. For 2.2 it should prefer what? 34.4. So what I can do, I can go and increase the weight of this particular neighbor. I can increase the weight for this particular neighbor. So what I can say, I can say neighbor ID 34.4. I can say weight, and you can see I can give a value between 0 to 65535. I'll say 500. Done. Check. Wait for it. Which path it is preferring now? 34.4. This is how we can manipulate. This is clear. Weight attribute. Now, right now you see this is altering all the routes, not just one route, but this is altering all the routes which are learned via the neighbor. Correct? Earlier, what was happening? Like if I want to go to 1.1 before this, even before this was the previous case. So 1.1, 34.4, Then for 2.2, 23.2, why? Because least A path. Okay, for 3.3, this is self-originated, and for 44.4 also 34. And then you see here it was preferring 34, then it was preferring 23 here. Okay, then it was preferring again 34. So I want that only this particular route should influence. So what we can do, we can create route map and we can attach. Right now you see that, okay, whatever the routes are learned via the particular neighbor, everywhere the weight has increased. But if you want to increase the weight only for a particular route, that also we can do. Okay, how? So let me go and say no here first. Okay, then so right now you see again it is preferring what? 23 dot. So now what I can say that okay, it will create first access list to select the network, access list one, permit 0.0.0.255, then we'll create a route map, rmap, permit 10. Okay, match IP address, access list one, set the weight, and weight I want to set for this route to 500. Okay, and for remaining routes, I want to keep it as it is. So I'll just increase the sequence number and not give it anything. Then I can go to router, BGP3, neighbor ID is 192.168.34.4. What is my neighbor? 34.4, right? So 34.4, and I can say route map, and route map name is up. This is done. How you want to influence inbound or outbound? Route is inbound. So do show IPv6. Okay. Do clear IPv6. You see, we influenced only a specific route. This is clear. Okay. No route map, map, no access one. It's clear. So it is selecting back. This is clear. Next attribute. Okay. Local preference, but before that, here you can mention about influencing a specific route. So I can say the above comment will influence all the routes which are to influence only a specific route. What we can do, create access list. Access list 1 to 99, permit, network ID, wildcard mask, and you'll create a route map. Commit, the sequence number, match IP address. Okay, ACL number. Set weight value. Then route map name. Higher sequence number. Then you will say router BGP ASN neighbor ID route map in whether you want to influence inbound or outbound. This is clear. So this was your first attribute. Second attribute, local preference. So again, higher local preference is preferred. Okay. There is a 32-bit value. Okay. Now again, this also it is similar to your weight only. It is similar to weight. Okay. How? It is also but when receiving a or receiving an update for any route. Okay. Then the default local preference is 100. Default local preference is 100. Okay. And this attribute is carried in the IB. That means it will be carried to your IBGP peers. So it will influence your entire ASM. So if you want to set local preference, you will say router BGP ASM. And then you would say BGP default local preference and the value. This is clear. Now take a look. Let's try to influence the same route. Right now you see here, this will be carried in IBGP. Need an IBGP. Because if I will change, if I'll say BGP default local preference, so what we can do is one time, let's say, if I go and check, so IPVGP. So here we can see right now how the routes are. It is using 1.1, 14.1 path. For 2.2, it is using 14.1. For 3.3, 34.3, and it is using locally injected, right? So let's go here and if I say, let's say 100. Default local preference is 100. That is fine. But that will not affect. This is for IVGP. Let's say I'll change it to 500. This will not affect anything. We need IVGP for this. Mhm. That option is not there. No change at all. If you think you can apply for a neighbor, let's say neighbor 192.168 or 34.4, so you don't have local preference option. Okay, you need IBGP for this because this is carried into IBGP. Hmm? You mean to say in route map? But again, that will be valid only if you have IBGP. Right now we don't have. So we'll see this one later. First, let's see the another one. Let's see next one first. Then next one is AS path. Now we know that router will prefer what? Least AS path. Clearing a BGP process, clear release software works soft. It doesn't clear the neighborship. If you do not use soft, it will break down the neighborship, form it again. So least AS path is preferred. So we can influence this attribute and we can, make a particular path as less better path. Okay, we can influence. So if you want to configure it, right? So how do you configure it? You'll say route map. This will be set in the route map. Route map name, permit, and then you give a sequence number. Then you say set AS path. And here you can give the AS values. Whatever the AS values you want to put in. So just give one spaces and keep on adding the ASs. Then you just add it to a neighbor. Router BGP ASM. Neighbor. Neighbor ID. Route map and route map name. Map name. And the direction inbound or outbound. This is how it's set. Meanwhile, the server is coming up. The last attribute, which is MED, stands for multi-exit discriminating. So MED is basically kind of metric, you can say. So least metric is preferred. So here, least MED is preferred. Okay. It is a 32-bit value. The default MED value, you can say 0 or none. Okay.
What is the 32-bit value?
It can have values from 0 to 2 power 32, right? So it is also known as matrix. So when you look at the output show IPBG, so it will be shown as what? It will be shown as metric one. Okay. So if you want to influence it, again you have to create a route map, influence the route. So what you'll say, you'll select the route. Access icon list 1 to 99. Permit. Network ID that you want to change MED for wildcard mask. Done. Create route map. Route map. Your route map name, permit, and sequence number. Then you'll see match IP address and here ACL number. Then you will say set metric and the MED value. Then you will use the command again for route map. Route map name, permit. For rest of the routes, we don't want to influence, so we'll use higher sequence number. Right? Router BGP ASM, neighbor ID, route map. Your route map name and inbound or now let me check. So what is the full one? Now after this BGP is completed, then we will discuss about tomorrow. Like tomorrow, we'll see about IGP resolution and IPSL and your open system. Okay. After that, you have like ACL topic. So ACLs you have already studied in your CCNA. So do you have a doubt in ACL? No. Standard ACL, extended ACL.
What is ACL? There are artificial route map and interface.
That is in the AGRP.
Yes, but when exactly will use access list?
Anytime you can use. See, access list, prefix list. Mostly you will use them as a selector with the route map. So you can use it anything. If you are not comfortable in prefix list, go with access list. No problem. The same thing is done. Okay.
Yeah. Okay.
They are different methods. That's it. Hmm? That is a slight difference, right? One in one place you are giving CIDR, in another place you are giving wildcard mask. Hmm. See, prefix list, if you want, you are talking about protocol, that will not be possible.
It is only possible.
As a selector, you can use it. R1 is there. R2. Then R3 and R. This is R1 configuration. R2. R3. R4. Okay. So let's go and check. Do show IP BGP. This is R3. Still the route will take time. Okay. So we have the routes. Right now, if we talk about R4, so if it wants to reach, not R4, let's go with R3 on. You will better understand it. Let's say this R3, if it wants to reach the 2.2, so it is using what? Which path? Why? The AS path is least. Here the AS path is longer, right? So what I'll do is I'll go and make this particular path as a worst path. That means I'll append more ASs here. Okay. So let's do it. I'll say route map, R map, atomic 10. Okay. Then I'll say, no need to match address. Set AS path, append, and then I can give ASs, like let's say, like this, I have appended few ASs, right? Done. Cannot have more than 10. Okay, so I have appended these many. Now what? I'll say router, BGP ASN number 3, neighbor ID is 192.168, and I want to make this one as a less best, or you can say a worst path. So I'll say route map Route map name is RMAP and in the inbound direction. Right? So now you see all the routes learned via that neighbor. Everywhere what happened? The AS path has been appended and they become least best. And you see my best path is here 34.4. Again, if you want that okay specific route, we will create an access list, and in the route map itself, we will attach the access list. That is clear. Okay. No route map. Okay, and then no need for transfer. So IP. All okay. Back to 23.2 as a first one. Okay, now let's talk about MED. So this MED is what? This metric here. Okay, this MED is what? Metric. So right now, let's say again, if I want to reach 2.2 only, what is the path? 23.2 is selected as the best path. Okay, what is the metric here? So if I will increase this metric will become lower. The metric through this path will become lower, and that should be selected as a best path. Okay, so only for specific route, if you want to manipulate again, so you can manipulate for specific route, or we can manipulate for all the routes also. Okay, so let's manipulate only for 2.2. Access list 1, permit 2.2.2.0, 255, route map bar map, permit 10, match IP address 1, set the metric, and metric, let's say 500 I'll set here. And for remaining routes, I want as it is, so 20. Okay. Then what I'll do is I'll go to a router, BGP, here's number 3, neighbor ID 192.168.23.2, and route map name is RMAP and inbound. Done. Clear IP BGP stuff. IP. The AS path is less. But just a minute. AS path. We have to talk about, somewhere we have equal path. Then only MED will be checked, otherwise MED will not be checked. So somewhere is there. No, I think here, right? This one for 1.1 we have, right? So 1.1 we can manipulate. So let the route map be as it is. We'll change the access list. Access list 1, permit 1.1.1.0, 0.0.0.255, and I'll say no access list 1, but that will remove everything. So right now, let it be. This will remain as it is. We just need to see only for the 1.1. Okay. But 1.1, it is selecting best route as. Okay, just a minute. No. Let me do the configuration from beginning only. We can append buckets. Okay. Let's not make it confusing by using two or more attributes. Okay. Then I'll say no route map RMAP, no access list. To IP, BGP. Now everything is good. Okay, so what we'll do is see here. Here the AS path is equal only. Okay, so right now it is checking according to oldest BGP route. Okay, AS path is same, metric everything is same, so it will check according to oldest BGP route. So this one we will manipulate. Right now it is using best path as 34.4. So on 34.4 side, we will increase the metric. Okay. So I'll say access list one, permit 1.1.1.0, 0.0.0.255, route map RMAP, permit 10, match IP address, and ACL number is 1, set metric 500. For remaining route, let it be default. And then router BGP 3. Then we need to check neighbor ID is 192.168. I want that, okay, this should be less preferred. So 34.4 route map, RMAP, and no. Clear IP. Fill this one. So still neighbor type is also eBGP. Oh. So both are eBGP, right? Wait a minute. So what we can do is, okay, let's try like this. We can go on R1 and we can manipulate. System. Okay, let me go on R2. Okay, this is 23.2. So from R2 side, let me send a metric of 200. Then let's check it. Enable terminal. Wi-Fi RMAP from 10 match IP plus 1 metric has 100 only. Then for remaining routes as it is, router BGP2 neighbor route map RMAP and outcome. So here I so IPBGP, it is not checking the metric. Uh, Come again. Hmm. And what is the comment? That one, let's check it. Ah, by default, it is not checking. Hmm. This one command extra, you note it down. That's why it was not checking. Okay, here, write down one more comment. BGP always compare and okay. This is one extra comment. Note it. Now, one last attribute we have about local preference. Okay, this is the command. BGP always compare. Now for local pref for that one. See, what we'll do is we'll make a single ASN. Delete, delete. Only slight change in the configuration. That's it. Okay, here. This will become ASN 23. This is only the change. So what I'll do, I'll say no router BGP to no router BGP 3. They both will become 23. And slight change here also. To show a pipe section BGP. Only for neighbor 3, instead of neighbor 3, we have to say it as a 23. Right? This will be in the 23. Same thing with the R1 also. This is not the ASN2, but 23. Done. And we just need to change the BGP configuration for R2 and R3. So first of all, R2, this is 23. Remaining networks and everything is as it is. This will be 23. Also 32. This is 23 and this is 23. Done. Copy. Done. Copy. Now again, they should have 2 neighbors, right? Now let's verify. To show IP. So, so, let's wait for it. So, 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 let's wait for it. Okay, so now we can see that for IBGP, the local preference here, right? So the local preference here is what? 100, right? This is the default local preference. Okay. So now if I go on R2 and if I say default local preference is 500, so this attribute will be carried. So right now, if I check, right, like, for 1.1, it is using best path as, it is using 34.4. Then here, this is local. Here it is using 23.2. Okay, fine. Then again, here it is using 34.4. So let's go and say BGP default local preference, and let's say fine. Done. Let's check. That. Okay. So BGP. Here it is same. And you see this is being carried in the IBGP. But why these are not preferred? So here IBGP. Mhm. Okay, this is for IBGP, right? Yeah. Here on R3. So 3.2 is using now this one. Okay, because it is using this one, right? 12.1. Let me give one comment here. This is how next stop self. Because of local preference it is, but earlier why it was not choosing, because the next stop was 12.1. Okay, so directly it is not able to reach 12.1. Okay, so once I give next stop self, we are good to go. Is that clear? So this is how your local preference will work. Understood? So it is carried in IBGP. Okay, that means it will be manipulating the routes throughout the layers. This is clear. So these are all your 4 attributes. So with this, your BGP is completed. Tomorrow we'll go with the redistribution part and IPSLA part. Then your routing is complete. Okay. Online people
Sir, still I did not have access.
for switching or routing?
So switching.
Switching access, right? Let me check.